Hi guys, these are our notes about finding the inverse of a log or exponential function. So in your table of contents, it's just going to be on slide 10 and 11, log and exponential inverses. So we did inverses. It was like the first part of our unit 4A, the unit that we're still in. And you guys did a bunch of log inverse or regular inverses. You did linear, quadratic, rational, radical, ones with exponents and everything. So now we're going to do inverses of log and exponential equations. So write down log and exponential inverses. What you need to remember is that the inverse of a log is exponential. And the inverse of an exponential is log. So what you need to remember is that if the problem starts off with a log, that your answer today will be exponential. If it starts off exponential, then your answer is going to be log. Let's write down our steps. So the first step is with any inverse is to go ahead and switch x and y. We're going to do an extra step, which is going to be to switch sides. This is going to put the exponential or log piece on the left side. That's where we need it to be. Step 3, you're going to go ahead and isolate your log or exponential piece. So your log base b of a or b to the power of something, you're going to isolate that piece. Then you're going to go ahead and do the loop trick to change forms. So this goes from exponential to log or log to exponential. Then you're going to go ahead and just solve for y. And last step is just to go back to function notation. Replace y with f inverse. Or g inverse or whatever, h inverse, whatever the original one had. All right, so let's go ahead and do some examples. All of our examples are going to be find the inverse function. Okay, so our first problem says f of x equals 3 to the power of x plus 12. So this is exponential. That means our answer is going to be log. So the first step is to switch x and y. Remember, this piece right here is your y. So when I switch it, it becomes x equals 3 to the power of y plus 12. Then step 2 is to switch sides. I'm going to be lazy, and instead of like rewriting it, I usually just erase this piece and then put the equals x on this side. So if you're using pencil, if not, you can just kind of scribble it out. All right, the next step is to go ahead and isolate your exponential piece. This is my exponential piece, my base to the power of something. So I need to move that 12 over, so I'm going to just subtract it on both sides. I get 3 to the power of y equals x minus 12. Step 3, or that was step 3, we isolated our log piece. Step 4 is to do our loop trick to change form. So this is exponential, so we're going to log form. So you start by writing the word log. Log base 3 of everything that's over here equals y. Log base 3 of everything that's over there. If there's more than one piece, you want to go ahead and put parentheses around it, and then equals y. Step 5 is to solve for y. Y is already solved for, so we're good there. We can go replace it with f inverse. I'm just going to go ahead and put it in the front since the y was on the other side anyways. And this is our inverse equation. So this is our original. This is our inverse. So notice how this original one had a 3 to the power of something. Our inverse is log base 3. So your whatever the base was on the original, your inverse is going to have that same base. Okay, so it was from exponential to log. You're going to go ahead and take a picture of this. This is going to be your the first slide. I think it was slide 10. You'll put your picture there, and then flip your paper over. We're going to do 4 more examples. I have a lot of examples for you today. All right, so our example says g of x equals 10 times 2 to the power of 3x. This is another exponential problem. So we're going to go ahead and find the inverse, which will be log. So I'm going to switch x and y, and then switch sides. So x equals 10 times 2 to the power of 3y. And then I switch sides. I'm going to put the x on the other side. All right, then I'm going to isolate my exponential piece. This is the exponential piece, 2 to the power of 3y. The 10 in the front is connected by multiplying. So the way that we get rid of it is we're going to divide both sides by 10. So we get 2 to the power of 3y equals x over 10. Then we're going to go ahead, and this is exponential, so we're going to do the loop trick to switch it to log. So we write the word log. Our base is 2 of whatever was on the other side, so I'm going to put parentheses around it since there was more than one piece, and then equals 3y. My last step is to go ahead and get y by itself, and then in order to do that, I'm going to divide both sides by 3. So y is officially by itself. We can go to function notation, f inverse of x. They wouldn't usually leave the fraction like this. They would probably write it as like a 1/3 log base 2 of x over 10. Technically, if we were condensing more, it would go as an exponent, and that would mean a cube root and everything, but it's fine, I believe, if you just leave it like this. All right, we have one more exponential example. So this one says 2 times e to the power of x minus 1. So again, as we've been doing, the first step is to switch x and y. So I get x equals 2 times e to the power of y minus 1. We switch sides. I'm going to put my equals x on the other side. That was step 2. Step 3 is to isolate your exponential piece. This is my exponential piece, e to the power of y minus 1. So in order to get rid of it, I'm going to divide both sides by 2. I get e to the power of y minus 1 equals x over 2. So now that my exponential piece is by itself, I'm going to go ahead and do the loop trick to change forms. So we're going to change it to log. The log base is going to be log base e, but we don't write log base e. We write natural log. That is log base e. On the quiz, a lot of people were writing like a 1 or an I there. That's an L. ln, natural log. Natural log of x over 2, I'm going to put in parentheses because there's more than one piece, equals y minus 1. Now we just have to get y by itself, so I'm going to go ahead and add 1 to both sides. It doesn't matter if you put the 1 in the front or at the end, as long as you have these parentheses so that you know that it's not part of the log. If you want to be safe, you can put in the front so that you know that it's not, but that's why we put those parentheses there to make sure that we know that it's separate from it. So if your original has an e, your inverse is going to have a natural log. If your original has a natural log, then your inverse is going to have an e. All right, 2 more examples. So my next one says 10 minus 2 log x. So I'm going to go ahead and start by switching x and y. So I get x equals 10 minus 2 log y. And then I'm going to switch sides. I'm going to write equals x. And then the next step is to go ahead and isolate your log piece. So this is my log piece, log base b of y. This is log base 10 of y. So this is the piece I want to get by itself. So I need to get rid of the 10 and the 2. So first I start by subtracting 10 on both sides. I get negative 2 log y equals x minus 10. And then the 2, I don't add it to both sides, I divide both sides by negative 2. And then to decide if I'm going to do one big fraction or 2 small fractions, the 10 can be divided by 2, so I'm going to do 2 small fractions. So I get log y equals negative 1/2 x plus 5, because the negative divided by negative is positive. All right, and then once log's by itself, I'm going to do my loop trick. So my loop trick, this was log, so now it's going to be exponential. The base for my new exponent, there's nothing there, so automatically it's a 10. 10 to the power of negative 1/2 x plus 5 equals y. And then I would solve for y, but it's already solved for, so I'm just going to go to function notation. And this would be my answer. So if your original problem had a log, this is just going to have a 10. If your original exponential problem had a 10, then your answer will have a log. All right, last example. So it says natural log of 4 minus 5x to the power of 3. Okay, so in order to start our problem, we're going to switch x and y. So I'm going to get x equals natural log of 4 minus 5x to the power of 3. And then I'm going to switch, that's not an x, that'd be a y, I'm sorry. And then I switch sides, so I put my x over here. All right, so from here, my goal is to isolate my log piece. This is my log piece, my natural log. There's a 3 there, right? So we want to get rid of that first. Well, if you remember from our expanding and condensing rules, that if there's a power, we actually can move it to the front. So it'd be 3 natural log of 4 minus 5y equals x. And then to get rid of it, I'm going to go ahead and divide both sides by 3. So now my log piece is by itself. Natural log of 4 minus 5y equals x over 3. So I'm going to switch this now. This is in log form. So when we switch it, it's going to become exponential. The log base is where we start. There's nothing there, but it's an e. So we do e to the power of what's here equals this. So e to the power of x over 3 equals 4 minus 5y. Now we just have to solve for y before we can have our final answer. So to solve for y, I'm going to go ahead and subtract 4 on both sides. So I get e to the power of x over 3 minus 4 equals negative 5y. And then I would divide both sides by negative 5. Neither of these can be evenly divided by 5, so I'm just going to go ahead and write it as one big fraction. Since there's 2 negatives though, we want to kind of distribute the bottom negative to the top, so we're going to distribute it. So it become a negative e to the power of x over 3 plus 4 all over 5. That's a 5 down there, but the page ran out. Oh no, can you guys tell that's a 5? Oh my goodness. Let me try to move all of this up. Oh my goodness. I'm making a mess of everything. There we go. So that's a 5. So you could put the 4 even in the front, 4 minus e to the power of x over 3 over 5, but usually we would distribute it to the top if there was a negative in the bottom. So if your original problem has a natural log, then you're going to end up with an e to the power of something. So remember, this problem had an e, its inverse was natural log. If you start with a natural log, you're going to end with an e. Okay? All right, now these notes go in, I believe it was slide 10 for the first part, and then slide 11 for the last examples. And then you'll have some practice problems for homework.